Okay, so I have the same 95 Jeep that we did a power balance test on that I took a little bit of electricity, and the test was really inconclusive. And although that's a valuable test and I can do it at home, the results aren't always as good. So now I'm going to pull out a high-tech tool where I'm actually going to use a scope that's laptop based. And what I'm going to do is I'm actually going to ID what vehicle I'm working on, in this case a 95 Jeep Cherokee 6-cylinder 4.0 liter. And what we're going to do is we're going to look at a couple things. I'm going to look at my number one cylinder, and I use that to put my cylinders in order. So we can see here, this has my firing order in it, 153624. I'm going to put this on number one, and I'm going to tell it that I'm going to trigger it on number one. Now the other thing I'm going to do is I'm going to put a probe in the tailpipe. And what the probe in the tailpipe is going to do is it's going to sense the pressure in the exhaust. So every time we have an explosion in a cylinder, pressure is created in the exhaust. When the exhaust valve, as soon as the exhaust valve opens. Now when the exhaust valve closes, we get a slight pullback, and then the next cylinder that has compression, when the exhaust valve opens, there's pressure that's released. If I have a cylinder that's misfiring, I'm going to have less pressure. So what I'm looking at is I'm looking at the change of pressure that I'm going to synchronize to the cylinders on the engine. Therefore, it should tell me which cylinder or cylinders are missing. So let's give it a whirl and see how we do. So I'm going to connect this to my number one spark plug. And this connects into my scope box here. I happen to be using the ATS Misfire detector with an older E-scope limited, and I have my pressure transducer, and I'm going to go put this in the tailpipe, and then we're going to start the vehicle. Okay, so I've started the vehicle. I can feel it's not running right. I've got everything set up. So at this point, I'm going to go tell it I want to look for misfires. And I can see here, occasionally this one has a lot less pressure, kind of goes over there. And what's neat about this software is it's going to count up. It's going to tell me how many misfires total it sees and give me a percentage. And it even changes colors, it counts out. So I can give this a little bit of time, see what it does. And you can see this, even though I could feel it, because I've been doing this for almost 40 years, you can see the misfire itself is not super severe. It's taking quite a while for this to kind of feel it and pick it up. I can also rev it up a little bit. And I don't feel the misfire when I'm revved up. I only feel it at idle. So since my engine was cold, because I didn't want to overheat the catalytic converter, I may need to let this engine warm up a little bit to really see what's going on. Or it could be a problem that's more prevalent cold, because I've been hesitant to run this vehicle with the misfire being so bad. So here we can see with the misfire detector hooked up, we are definitely got some misfire in number one. And this is where the software is really helpful, because I got it kind of tailing off over here at number 4, but really number 1. Then software is figuring the offset and telling me conclusively which cylinder is misfiring. This is the same misfiring cylinder I suspected with a conventional power balance by disconnecting the spark plug wires, but it wasn't as conclusive. This is conclusive. This is something I can show to the customer, and this also tells me my next step is to check for spark and fuel. If I have spark and fuel, at that point, by default, it has to be a compression problem. So if I have good spark and I have fuel in the cylinder, it has to be compression. And since those are the easiest thing to check, we're going to check those next. But clearly, cylinder 1 is why I'm misfiring. Okay, so we've identified cylinder number 1 as the misfiring cylinder. So we need 3 things in order for that cylinder to operate. I need spark, I need fuel, and I need compression. So the easiest thing to check is fuel. Now there's 2 parts of fuel. Am I getting an electrical signal to the injector? And is the injector putting fuel into the engine? My ignition, I need to know, am I getting at least 30,000 volts to my spark plug? That being said, I could have a bad spark plug, so I might be swapping those in a minute. But again, I always want to start with the easiest test and work my way further down. Again, just like if I got to take the spark plug out to move it or to inspect it, I'm going to do a compression test at this point. So some cars are easy to get the spark plugs out, some are a lot harder. So really what I want to do at this point is I want to check, am I getting an electrical signal to my injector, and am I getting 30,000 volts out my spark plug wire? And then what I'm going to do is if I'm getting a good signal from my computer to my injector, is I'm going to plug that connector back onto the injector and let it run a little bit. And that way when we pull the spark plug out, if I have gasoline on it, I know the injector is working because there's no spark there. On the other hand, if I pull it out and it doesn't smell like gasoline, then I got to really wonder if the injector is my problem. So instead of taking the whole fuel rail apart, taking the whole injector off and going, I don't have a bench test, or I'm just going to go buy one and hope it fixes it, or I'm going to move injectors from one cylinder to another, all that's a lot of work. I might break stuff, I might need parts. It makes a lot more sense. Let's check for an electrical signal. If I can prove I have an electrical signal, let's plug it in. Let's see if it can put some fuel into number one cylinder without a spark plug connected to the ignition system. Let it run a minute or so, and then we'll pull it out and see if that sucker smells like fuel. If it does, and if it's wet, or if it even smells heavily like fuel, then I know what? My injector is actually putting fuel in the engine. At that point, I've already got the spark plug out, so we'll do a compression test next. So the two tools I'm going to use is I'm going to use a calibrated spark tester. This is an HEI spark tester. It's calibrated for 30,000 volts. And if you notice, there's no center electrode sticking up here. So I just clamp this to ground and put the spark plug wire on it. I've already done that with another one that I have. And this is what's called a Noid light. And we have a lot of different Noid lights. They have different electrical configurations. And what you do is you just unplug the injector connector off the injector and plug the Noid light in. And the Noid light will flash if there's a signal from the computer. So neither of these tools are real expensive or real high tech. They're simple, but they give me a whole lot of information. And my motto is, how can I get the most information with the least amount of work? And these two guys are it. So let me start this vehicle up and let's take a look. I've already hooked the set up on the car. So let's take a look and see what we got. So I can see here, I've got a nice spark, 30,000 volts jumping. You can also hear it. I've also got my Noid light flashing. It flashes every time the computer's turning on the injector. So since I know the computer's doing that, I'm going to unplug it and plug it into my injector. And I should be putting fuel in the cylinder. I can also use a stethoscope to listen if the injector is clicking. So I've got a stethoscope here with a metal wand on it. I'm going to put this on the end of my stethoscope, and the sound that the number one injector makes should be the same as the other ones. And I can hear it, and it's clicking right away. So that means it's opening as far as being a command. Mechanically, the solenoid is moving. The only question left is, did we actually put any fuel in the cylinder? So I'm going to shut it off, and we'll pull out the spark plug. So I've got my spark plug out. Oh, it definitely smells like gasoline, so we've been putting some fuel in. I can look at the spark plug. It looks worn. It looks like it's getting about time for spark plugs. So it could be my problem. But while I'm here, I'd like to do a compression test. So we can do a compression test with a gauge, or I can do a compression test with my scope. So I'm going to set my scope up to do a compression test. So in order to do that, I'm going to need a couple things. And what I need is I need an adapter to go into the spark plug hole, and I need a transducer that's going to connect electrically from here to my E-scope limited. And by connecting to the E-scope limited, then I can get a pattern of my compression waveform. So instead of just getting a cranking compression test that tells me if it's sealing, or a running compression test that tells me if it's breathing, I can get both of those by having this hooked up and starting the car. On top of that, I can also see if my valves are opening correctly, if they're not sealing. And since we have an intermittent problem where we can see sometimes I'm misfiring and sometimes I'm not, I can look at each compression cycle separately to see if they all look the same. So I'm able to get a lot more information than just doing the simple compression test that we talked about in other videos. And I'm going to disconnect my thing again. Let's hook the Noid light back up. So I'm not putting fuel in, which might change my compression readings. And let me get the lead to go to the scope. Now I can do this a couple different ways. I can use the software that I have here, and I can come into my Intelligent Engine Analyzer, and I can tell it, hey, I want to configure it, and actually I want to do compression. Now I'm going to tell it I want to do compression on my 4-liter. And the reason why it wants to know that so it can set the right valve timing. So I'm going to kind of wake it up here, let it know I'm selecting that, and I can click Begin Analysis. So once I hook this up, we can see here my compression waveform, and the software is going to pick out several points on the waveform and compare them, and I'll get little red lights if it doesn't see something it likes. So this is great because this is a scope on training wheels. I can also go in and just use my scope and get the pattern and try to interpret it myself. But we're going to use this for this demonstration. So let me get this connected and we'll start it up. Okay, so I'm all hooked up. I'm going to start this and let's see what we get. But I can see I'm getting a little bit of flicker on the exhaust opening. I can see a little bit of the exhaust intake PSI it doesn't like. Let's see if I can get a better pattern by going over here to measure. And here we go. Now I have a pattern. So I can see right here, my running compression is right about 57 PSI. I come down here, here's top dead center of my compression. I come down on my power stroke and my exhaust valve opens. And if I look here at the bottom of my exhaust valve, it should be a nice smooth dish. And you just saw just now we had a little hiccup on it. Just saw it again. And then here's my exhaust plateau over my intake, and here's where my intake's supposed to close, right about 50 degrees. And if I'm looking at my exhaust valve right here, if you look at my exhaust slope, this should be smooth, and you watch it, you see occasionally we get a little bump there. There it was again. So what's causing that? I have an exhaust valve that's not seating. I have a little piece of junk or something in the seat, either a slightly worn spring or a piece of carbon or something is interfering right here on my exhaust slope. If I look over here, my intake looks pretty consistent. But if I watch that, I'm definitely having an intermittent problem right there. And what's interesting is they're all happening down right around neutral pressure or slightly under. So this is 0 PSI. So underneath this, I'm in vacuum. My line is going up, it's not going down. That means it has to be an exhaust valve. If it was an intake valve, it'd go down because I have more vacuum than 7.5 inches of mercury. So if it was intake valve leaking, I'd be leaking into vacuum. The spike would have to go down. If it's an exhaust valve leaking, my spike has to go up. That's why it's important to understand all the pressures, both on the intake side and the exhaust side. But I can see, so I have a running compression test. So let's change scope settings. I'm going to go to just a regular scope where I can do my cranking, running, everything in one and record it. So I'm actually going to leave this program and I'm just going to go into a regular scope. I want to deep record channel 3 because that's the channel I'm using. Start deep record. There we go. And what I'm doing is I'm just stacking these up right now. So I'm going to stop deep record here. I'm going to shut the car off. Now keep in mind when I do my cranking compression test, I don't have a Schrader valve in the bottom, so I'm going to have a little bit lower cranking compression than I have with a gauge that I can pump up. But I'm going to click Start Deep Record. So I'm idling. So what I've just done is a cranking compression test, a running compression test, a snap compression test, and back to a running compression test. And if you notice, the car's not running anymore. Why? Because I've got all my data. With the other tool, I'm sitting here listening to it, the bay's getting hot. It gives me a lot of analysis, which is great, but if I know what I'm looking for, I can actually use this. So now what I can do is I can come in here and I can use my zoom window. And let's take a look at our cranking compression. And what I want to do is I want to see, are they the same? So the first one's probably going to be a little bit different because that's the first time the engine's going around. So let's kind of concentrate on these, which we probably started running real quick. There we go. And I can actually come in and zoom in on just one. And I can see what the pattern looked like. And what's more important is now I can compare out to, I can go back here and I can look at something else. So I can go in here and I can continue to use different settings and look at different ones and see if I see something that doesn't look right. I can also come in and compare several of these. And these are all looking very similar. So some of the anomalies I saw with the other scope is not the same as I'm seeing here. Now I'm on a voltage scale here, so if I want to get a little clearer picture, I can change my scope. So here, instead of 20 plus or minus 20 volts, let me tell it I'm going to use it a different transducer. I'm going to use a 300 psi transducer. And let's take a look and see how that clears up my signal. And see now how I've got pressure instead of just a voltage reading? So now I can come in and zoom in on this. And it kind of looks like a mess because I got a lot of things going on. So I really only want to look at channel 3, so I can turn off the other channels to just look at channel 3. It's still there. I can bring it back. Oh, I want to compare it back to channel 2. There we go. Channel 2 is my ignition. That's when my spark plug fires. So I can actually go in here and look and see where my spark plug fires compared to my pressure. I can also look at how even I am, and I see I got a little stuff here. So I want to take a closer look at this. There you go. There's my exhaust valve that's not seating right there. The kick we see here is from the other spark plugs firing. But there you go. I have an exhaust valve that's not seating. There's junk in the seat. So I have a couple choices. I can pull the cylinder head off. It's got 175K on it. Or I can try doing a top end cleaning to dissolve the carbon off and see if it's going to fix the problem. And here I think it's more of a carbon issue than it is a burnt valve issue, because if it was a burnt valve, it'd be burnt all the time. If it was a seat that's distorted, it'd be distorted all the time. The fact that it's so intermittent, even though it's consistent, leads me to believe it's a carbon issue. So we're going to do a top-end clean on this vehicle, probably swap out some spark plugs, but I don't see a spark plug being it. But just, again, diagnosis is all about eliminating things and not assuming stuff. So I'm going to take my spark plug from number 1 cylinder, I'm going to throw it into a different cylinder, and then I'm going to come back and I'm going to go and check and make sure that cylinder 1 is still the cylinder that's misfiring. So hopefully by looking at this, I was able to expand your horizons, give you some different ideas on how we can test things, and again, really look at different ways of getting information from the vehicle based on the equipment we have available to us.